All right, hello and good morning. In this video, I just wanted to show you a quick video describing what engineering economics is and kind of what we're going to be talking about and doing in this class. Okay, so hold on. So, what roles do engineers play in making decisions, especially in the business department? And really it comes down to like the design, the manufacturing, the buildings, the machinery, could be marketing, shipping costs. Okay, take for example like Google. um, they have great ideas. They need computers, they might need monitors, cables to do what they need to do. So they need to some sort of make an educated guess by using engineering economics to say, okay, how long is it going to take to pay back? How much do I need to invest now? What's my money worth now and in the future? And really, what is my return on investments? Okay. So, for example, here is so say you have a machine part is manufactured at a cost of 40 cents for material and 15 cents for direct labor. You invest 500,000 in a tooling that's required. The order calls for 3 million pieces. Halfway through the order, managers learn that a new method of manufacture could be put into effect and it will reduce the unit cost to 34 cents for material and 10 cents for labor. But it will require $100,000 for additional tooling. All right. So right here, you kind of have like halfway through this manufacturing process, you have a decision to make. Do you keep doing the current setup or do you actually buy this equipment? And so you can use this engineering analysis by looking at alternative A and alternative B and figuring out which one's going to actually cost the least. Okay, in this case, changing the manufacturing process actually is a significant decrease. Looks like $200,000. Okay, so it could save the company a lot of money, which then they could use to invest in something else. Okay, so so that's kind of like the main what do you want to call it? The main concept of engineering analysis, and throughout the whole semester, that's what you're going to be thinking about. All right. So, for example, here is some sort of homework assignment that you'll eventually do, where you have a bridge cost 15 million with annual cost. You want to find what this capital equivalent cost would be, okay, which is kind of what is it per year kind of thing. So you would, just like engineering problems, have engineering format where you write down your givens, you have a sketch, and we'll talk about this in the next video what these sketches mean. You have equations, you plug your numbers in, and you can figure out basically how much this bridge is going to cost per year with these different interest rates. Okay. Interest rates are huge because sometimes you need to borrow money from a bank, and if it's 5% or 10%, what is that cost going to be in the future? Okay, and the value of money is always changing. So the present value of something, the future value of something is going to be different. So we need to really evaluate that, and you can do that with engineering analysis. Okay, so you may end up making some graphs to show stuff. Again, very important that you have sketches to identify your costs. All right. Um, One of the main things, and we'll get to this later too, is this chart in your book. I believe it should be on your front cover as well, but it's also table 3.6. This is probably the most important table in engineering analysis or economics, because you have these equations or formulas that talk about that have what we call a future value, a present value, which is P, interest rate, which is I, and the number of times it compounds or whatever is called N. Okay. So, for example, just to give you an idea, looking for this one right here, capital recovery, this equation A, this equation, okay, is used to find your annual payment for, say, your car or your house, okay? So if you buy a house for, which is P, which is a down arrow of, say, $200,000 at an interest rate I of 10%, then you can use this formula to figure out your annual payments, okay? And say that every month you're going to pay $200, and it's going to take you 8 years or something, okay? So N would be, in that case, the number of months. All right, so that's cool, right? So this is one formula that you can use. These other ones are talking about, like this one up here is saying, well, what is the future value? All right, say 2 years down the road, if I gave you $100 and I charged you 10% interest, how much am I going to have to, or how much are you going to have to pay me if I let you alone? Okay. So again, there's certain equations for certain conditions. These linear gradient are, say you get a bonus every year of $2,000, that keeps adding, and so you can use these formulas. So again, very important table. We will always use these equations pretty much throughout the entire semester because they have the time value of money incorporated in these. All right. So this is, again, a video just to talk about what engineering economics is, to give you an idea so you can start thinking about what we're going to be doing. All right. Take care and enjoy your semester.